Hi, this is Roopa Prasad, Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss about the topic called as RSA Cryptosystem. So in this one, we are going to see the contents. So first we go for the basic concepts of RSA. Then we go for the general idea of the RSA algorithm. Then we go for the key generation, and then we go for the encryption. Then we go for the decryption. So first coming to the basic concepts. So, this RSA is the most commonly used public key cryptographic algorithm, or we can also see it as a asymmetric key cryptographic algorithm. So, this is one of the most popular asymmetric key cryptographic algorithm. So, as we already discussed, this cryptographic algorithms are of two types. One is called as symmetric, other one is called as asymmetric. So, this RSA is an asymmetric cryptographic algorithm, or we can also say it's a public key cryptographic algorithm. So this RSA is an algorithm which was invented by three persons by name Rivest, Shamir and Edelman. So we call this algorithm by their names Rivest, Shamir, Edelman algorithm. That is nothing with the RSA algorithm. Okay, this RSA algorithm make use of two exponents. One is called as E and the one is called as D. Whereas this E is public and D is private. Okay, as we have already discussed in previous sessions and the principles of public key crypto system, that this asymmetric key cryptographic algorithm mainly focuses on numbers, whereas symmetric cryptographic algorithm focuses on characters. So here we are going to make use of the mathematical functions. That means we are making use of two exponents. One is called as E and the one is called as D. Okay, where this E is public and D is private. Suppose if you want to encrypt the message or if you want to decrypt the message, so what is going to happen in RSA means, suppose P is a plain text and C is a ciphertext. So Alice, who is a sender, he is going to get the ciphertext by having this formula, that is P power E mod n. P is a plain text, P power E mod n, where E is a public key. So this, by using this, he is going to create the ciphertext which will be sent to the receiver, that is a Bob. So in order to decrypt the message, the Bob uses the formula C power D mod n. That is C means ciphertext, D, that is a private key mod n, in order to retrieve the plain text sent by Alice. So here we are going to make, using this algorithm, in this particular algorithm, we are going to make use of two exponents. One is called as E and the one is called as D, whereas E is public and D is private. And this modulus n is a very large number that is created during the key generation process. This modulus n is going to be created during the key generation process. Then we will see how it is going to happen. Okay. So this encryption and decryption algorithms use modular exponentation. So in the encryption process as well as the decryption process, they are going in this particular algorithm, in the asymmetric key cryptographic algorithm, we are going to make use of the modular exponentation. So this modular exponentation is feasible in polynomial time using the fast exponentation algorithm. In order to find this modular exponentation, we are going to make use of fast exponentation algorithm, which is feasible in polynomial time. So in order to decrypt, so encryption can be done in polynomial time. In order to decrypt, without using the private key, we cannot able to decrypt. So opposite for this exponentation is logarithm, which is very hard as factoring the modulus, for which there is no polynomial algorithm yet. So for this purpose, security purpose only, we are going to make use of the modular exponentation. And this Alice can encrypt the message in polynomial time, and Bob also, that is receiver, can also decrypt the message in polynomial time if he knows D. Okay, without knowing D, the Bob cannot able to decrypt the message. Bob is the intended receiver, so he can able to decrypt the message in the polynomial time. But any other party, that is a third person, Eve cannot decrypt the message because he does not know D. If he knows D, then only he can able to decrypt the message in polynomial time. If he does not know D, then it is not possible to calculate. So he has to calculate the eth root of C using the modular arithmetic. So which is not completed in the polynomial time, which is not feasible. And so what we are going to say is this Alice, that is the sender, uses one-way function. Okay, with a trapdoor known only to Bob. As we have already discussed, one-way function. So what is this one-way function? One-way function means we can calculate y if we know the x value. By giving the x value to the function, we can able to calculate y. If we know x value, then we can able to calculate y. If we know y, then it is not possible to calculate x. That we call it as a one-way function. One way only. We are going to apply the function in one way. We can calculate y if we know the x value. If we know the y value, then it is not possible to calculate the x value. When it is possible, if we know the trapdoor, that is called as a one-way trapdoor function. Trapdoor means it's the key, the secret key. If we know the secret key, then only we can able to calculate x by knowing the y. That is, by knowing the ciphertext and key only, then only we can compute the plain text. So the E, which is a third party, he does not know the key, so he cannot able to decrypt the message. That's what in this diagram we have explained. So this alias, that is, the sender is going to encrypt the message by using the public key. And this if we know the key only, that is the private key only, we can able to decrypt. Okay, if we don't know the private key, then we have to find out the eth root of C, which is not possible to execute by the Eve. That is a third party. So for that purpose only, we are saying this as a one-way function. And now we come to the general idea of this RSA algorithm. So in this RSA algorithm, we are going to make use of two algebraic structures. There are two algebraic structures are there in RSA algorithm. One we call it as a ring, and the algebraic structure is called as a group, ring and group. Okay, this ring is used for the encryption decryption process, whereas a group is used for the key generation process. Actually, in RSA, we have the three algorithms are there. One is used to generate the key, one is used for the encryption process, and one algorithm is used for the decryption process. So for this encryption decryption process, we are going to make use of the algebraic structure called as a ring, whereas for the key generation process, we are going to make use of the algebraic structure called as a group. Then we see what is this encryption decryption ring. So in this RSA algorithm, encryption and decryption algorithm are done using the cumulative ring, that is R, which is a set of Zn and plus and into. That means here we are going to use two arithmetic operations, that one we call it as a addition and one we call it as a multiplication, and modulus Zn, that is set residue is Zn. Okay, so in RSA algorithm, this ring is public. So this ring is public because the modulus n is public. Anyone can send a message to receiver, to Bob, using this ring to do the encryption. So public key is announced to everyone. So by using the public key, anyone can send the message to the particular receiver. And coming to the key generation process, and here what happens in this key generation, Bob uses a key generation algorithm. Bob uses the key generation algorithm, which makes use of the algebraic structure called as a group. Okay, so here what the Bob is going, Bob means the receiver. What the receiver is going to do means he is going to use a key generation algorithm to create his public key and private key. So after the key is generated, Bob announces the tuple e comma n as a public key, and Bob keeps the integer d as his private key. So what the Bob is going to do means he is going to execute one key generation algorithm that we will discuss later. So in the next slide we discuss. He uses a key generation algorithm. By using this key generation algorithm, he is going to create two keys. One is called as a public key and one is called as a private key. Okay, this public key is viewed as a tuple, which he is going to announce to everyone on the network, whereas the private key is kept a secret. Here we are calling the private key as D, and this private key is kept a secret. Okay, so in order to have more security, so the prime number, the size of the prime number is usually 512 bits, that is almost 154 decimal digits. For the security purpose, we are going to make the prime number size equal to 512 bits. Okay, and if we keep the 512 bits as a prime number, then obviously the size of the n will be 1024 bits. Why it is so, we will see in the algorithm. Okay, so the recommended size, in order to have the security, but to be more secure, the recommended size of the prime numbers P or Q is 512 bits. So if it is 512 bits, obviously the size of the modulus n will be 1024 bits. And this key generation algorithm is executed by the receiver only. Okay, as we have already discussed in the principles of public key crypto system, that security is on the burden of the receiver only. So the receiver has to execute the key generation algorithm, and he has to give his public key to the public key to, is to be announced, so that the sender can be able to use his public key, and he can able to encrypt the message, and he can able to send to the receiver. So this is a general idea of RSA. So Bob is a receiver. So key calculation will be done by the receiver only. So here he is going to make use of the algebraic structure called as a group. So in this group is a set of z of pi of n and division and multiplication. Here two arithmetic operations are allowed. One is a division and one is a multiplication. This algorithm we'll discuss. So by executing this algorithm, he can able to find out the public key as well as the private key. This public key and this modulus n will be announced to the public. So can the sender can be able to use these keys, and this private key is kept a secret. So any sender, suppose the alias is going to send a message, he is going to make use of the public key which is announced by the Bob. So by using this key only, he is going to encrypt the message. So for the encryption process, he is going to make the algebraic structure called as a ring. So on this, by using this key only, he is going to encrypt the message, and he is going to get the ciphertext, and that ciphertext will be sent through the receiver through the transmission medium. At the receiver end, that is at the Bob end, the Bob is going to apply the decryption algorithm, which is a ring structure, and he is going to make use of the private key called as D in order to get the plain text. That is a general idea of the RSA. As we already discussed, the receiver is responsible for generating the keys. The key calculation will be done by the receiver. So the every system is going to have a pair of keys. That pair of keys will be generated by this receiver. He is going to announce this public key to the public, and he is going to keep the private key as private. Okay. So next we will see the key generation algorithm. So this is a key generation algorithm. See here. So here the first step is you have to select two large primes P and Q such that P is not equivalent to Q. Okay, so we have to select two prime numbers P and Q. We have to select two large prime numbers P and Q such that P is not equal to Q. Okay, so already we have discussed that in order to have to be more secure, this P recommended size of P or Q will be 512 bits. Okay, so if this is 512 bits, then obviously the size of n is 1024 bits. So how we are going to get compute n equal to P into Q, n equal to P into Q, then we have to find out pi of n. Then we have to find out pi of n, which is used to calculate the private key. So pi of n equal to P minus 1 into Q minus 1. Okay, so we get the pi of n. Then we have to select one integer e such that it should lie between 1 and pi of n. Okay, e should be in between 1 and pi of n, and this e should be the co-prime of pi of n. That is, it is relative prime to pi of n. E and pi of n are relative primes. Okay, then we are going to calculate D, which is called as a private key. Inverse of E, we are going to take the multiplicative inverse of E mod pi of n. E inverse mod pi of n, then we get the D, that is a private key. So public key will be E comma n, that is the E, this one, where we have selected E, and pi of this is n, that is P into Q, and private key will be D. Okay, this public key is announced to public key, publicly to every to the network it will be announced, and whereas this private key is kept a secret. Okay, so in this key generation we are going to get two keys, a pair of keys. One is called as a public and one is called as a private key. Once again I tell you. So what the key generation algorithm? Here we have to select two prime numbers. One is called as P and another one is called as Q. These prime numbers should be large enough. So, and this there is a condition that this P should not be equivalent to Q. Okay, then we have to calculate n equal to P into Q. Then we have to calculate pi of n. How we are going to calculate means P minus 1 into Q minus 1. Then we have to select one integer called as E. This E should be in between 1 and pi of n, and this E should be co-prime of pi of n. That is, E and pi of n are relatively primes. Okay, then we have to calculate d equal to E inverse mod pi of n. Then that is called as the public and private key. Public key is called as E comma n, private key is d, and that is the value we are going to return from the key generation algorithms. Okay, hope that this is clear. So this key generation algorithm is done by the receiver only. Okay, and RSA algorithm. So anyone can send a message to Bob using his public key, because public key is announced to the public. So anyone can use the receiver, the Bob's public key to send the message. And encryption in RSA can be done using the algorithm with polynomial time complexity. So in this RSA encryption algorithm is done using polynomial time complexity, and the size of the plain text must be less than n. That is a condition here we are going to impose. So n is nothing but what we have calculated, modulus n equal to p into q. Okay, this plain text, size of the plain text must be less than n, which means if the size of the plain text is larger than n, it should be divided into blocks. Okay, then if the size is more than n, then what you have to do, you have to divide into blocks, okay, of each size n. Okay, and we see the RSA algorithm. Okay, so this is the RSA algorithm. The arguments for this is P, that is a plain text, E and N are the public keys, which we have received from the receiver. Okay, receiver is going to calculate the public key and it is announced to everyone. So by using these keys, we are going to perform the encryption algorithm. Here we are going to use the fast exponentation. That is, for this calculation, we are going to use the fast exponentation. So C equal to P power E mod n. Okay, then we are going to return C. That is the ciphertext we are going to return, and that ciphertext will be sent through the transmission medium. So at the receiver side, we have to perform the decryption algorithm. So Bob, you can use the decryption algorithm to decrypt the ciphertext message he received, and the decryption in RSA can be done using an algorithm with polynomial time complexity, and the size of the ciphertext is less than n. Okay, if the size of the plain text is less than n, obviously the size of the ciphertext is less than n only. If the plain text size is more than n, then what we have to do, we have to divide the plain text into blocks which is of size n. Okay, so we see the decryption algorithm. So this is a decryption algorithm. In the decryption algorithm also, we are going to make use of the fast exponentation. So what are the parameters for this? One is D and N. D is the private key and N is a modulus. So C is a ciphertext. By calculating this one, that is B equal to C power D mod N. And how this exponentation is done by using the fast exponentation, and it is receives the plain text, returns the plain text. That is a decryption algorithm. So in the RSA, RSA is a public key cryptographic algorithm, or we can also call it as a asymmetric key cryptographic algorithm, which is named after three inventors, that is Rivest, Shamir, Adelman. So here it is going to make use of the modular exponentation. And this in RSA, we have three algorithms are there. One algorithm is used to generate the key, another algorithm is used to perform the encryption, and another algorithm is used to perform the decryption. That is the RSA algorithm. And these are the references. And if you have any queries, you can drop here. Hope you understand. Thank you.